Hello, my name is Connor Druin, and for my next presentation in this mini series of presentations I'm doing, I would like to discuss the paper written by Dorina Casoni, Simona Codruța and Ileana Simion, entitled Feasibility of UV-Vis Spectroscopy Combined with Pattern Recognition Techniques to Authenticate the Medicinal Plant Material from Different Geographical Areas. Specifically, the reason I wanted to do something on UV-Vis was because this is the first piece of equipment I really got significant use with after my undergraduate degree, and I always felt like in the industry I was working in, we really used 1% of what it was capable of, and so I was interested in finding out more about what's truly capable of. For the uninitiated, UV Vis, just very quick and dirty explanation, is effectively a beam of light is shot through a sample, liquid sample, usually a cuvette, sometimes on a small microliter amount on a pedestal in the case of like nanodrop, and then the amount of light that is absorbed can be used to determine a concentration through Beer's law. At least that is the 1% capability that we used it for in my industry. Anyway, so um, Kasani and all the team who worked on this sought an analytical method using UV-vis spectroscopy to determine the quality of commonly available medicinal plants from European regions like Macedonia, Poland, Germany, as well as Asian regions like Kazakhstan, Serbia, and Russia. These substances include licorice, St. John's wort, and juniper, in addition to a variety of other known plants that um, historically have been used for antibiotic and anti inflammatory effects. The team wanted to prove that the polyphenols, more specifically the spectrographic data as from the resultant scan of these polyphenols contained within these medicinal plants, could be used as sort of a fingerprint to determine the purity. For example, rutin is a polyphenol present in St. John's wort. You can see here table of all of the different plants that were studied, as well as the regions that they came from. The extract from these oils is what was specifically scanned for. Um, the team ground the material using a ball mill, followed by an extraction of the oils, 70% ethanol by volume. Sitting for 10 days, the extracts were decanted and washed with an additional 70% ethanol by volume and diluted to 25 mLs. The measurements were recorded from 200 nanometer to 800 nanometer using a double beam spectrophotometer with a 10 millimeter quartz cell. The resulting spectra were processed using HCA, PCA, and DA analyses. I will elaborate on that a little bit later. Of the 52 samples from the 12 different medicinal plants, each spectra was broken down into two primary ranges: 200 to 380 nanometer, or 220 nanometer to 380 nanometer, uh, which is associated with flavonoids, flavones, and flavanols, as well as their derivatives, and the 400 to 700 nanometer range, which is associated more with carotenoids, anthocyanin, tannins, and chlorophyll. Uh, Using HCA, which is hierarchical clustering analysis, as alongside Ward's method, which I'll elaborate on a little bit here. Each sample was clustered into one of four groups, each certified across corresponding certified samples, cross-referenced. Um, Juniper and peppermint samples were divided into distinct subclusters due to their increased complexity and the resultant patterns. Um, Derivative spectra were used to enhance the resolution, reduce baseline shifts, and increase curvature, making the absorption more apparent. PCA analysis combined with Varimax rotation evaluated the first, second, third, and fourth order derivatives of the original spectra, maximizing the variance of each principal component. These derivatives of the loading profiles from the PCA Varimax highlighted differences between close regions of the spectra, narrowing the spectral domains, and following the Varimax Max and PCA DA was used, considering eigenvalues only of anything greater than 1, with each derivative containing an increasing number of principal components. Each derivative, as a result, demonstrated an increased accuracy in differentiating between medicinal plants via the UV spectra. So there were a lot of terms in that. To briefly discuss the actual method itself, so hierarchical clustering analysis as I mentioned, was a method used as part of their determination. This method can either be top down, where all points in one cluster are slowly differentiated, or bottom up, where all points are start as separate clusters and are slowly merged as they raise in hierarchy. Ward's method is simply a popular bottoms up approach to HCA, which is what they used. Purposes For the purposes of this study, HCA was used to prove reference materials of known composition would be clustered with unknowns of the same composition, regardless of origin, um, and then spread across as it goes down. The hierarchy would separate into different regions. This was done successfully, with the exception of peppermint, as I mentioned earlier, which varied from references to form two different subclusters of 4.4. This over here are the different subclusters. You can see two different subclusters for peppermint here. Um, the next technique they used, PCA Verimax, or principal component analysis with Verimax rotation, is another analytical tool to assist the interpretation of UV data. Simply put, it reduces the dimensionality of a set of principal components to make the information more easily interpretable. This is done by treating each principal component as an eigenvector and performing an eigendecomposition to linearly transform the information onto a new coordinate plane, where outliers and variances are more easily identified. The team used this method to generate clusters of principal components, which the team identified as markers for identification, labeled them as factors 1, 2, and 3. And these factors uh, were initially very broad, showing very little differentiation within each factor. However, with DA, these factors were narrowed. You can see here, this is the initial scan with 10 principal components. First derivative, second derivative, third derivative, and then fourth derivative. And as these derivatives continued to increase, the number of principal components increased, which revealed more precise regions within these different factors that tied more closely to identifying various plants. These additional factors steadily increased the accuracy as well, as mentioned earlier, resulting in a 98.1 accuracy for the third level derivatives and a theoretical 100% accuracy for the fourth derivative. However, the team never uh, truly did a fourth derivative analysis according to the paper. So, strong and weak. So, what are the strengths and weaknesses as I see them for this study that the team did? So for strengths, the use of the enhanced spectral analysis tools like HCA, PCA, and DA is what allowed this study to actually take off and prove their theory that they could identify plants from different regions based on this data. This was proven through the 98.1% accuracy they got through third derivative analysis, and proved that was viable for differentiating samples of geographical origin. The Verimax rotation clarifies which spectral bands contribute most significantly to this variance, and geographic botanical diversity of the actual study itself shows that it may be applicable to even more medicinal plants beyond what the team tested. Um, as far as weaknesses, the range was kind of limited. It was UV vis from 200 to 800 nanometer, which does not touch into the IR range. I'll cover this in sort of my suggestions. The effectiveness of the results also heavily depended on the pre-processing steps. Even small changes in the smoothing parameters could cause a great variation in the resultant data. Although the study does incorporate various plants from a wide range of regions, it is never clarified how many samples came from each region or each group. So there could have been, one sample from Russia, but 30 samples from Serbia, and so that could also contribute to sort of a large variance or in the discriminant analysis, where there's not enough data to really support correctly identify the Russian sample. It also lacks any sort of real world utility for that reason. Um, the paper demonstrates high classification of performance under controlled experimental conditions, but as I said, no real world testing or conditions were used. And as far as the variation between botanical components, the paper doesn't really. It briefly mentions how roots and leaves and stems will all have different concentrations of the necessary chemical components, but it doesn't really standardize what they used. So suggestions: updating the software or the equipment used to UV vis near, which would be including IR, so a further range would go a long way to enhancing these factors that they created. Standardizing the group size again, like I said, making clear how that there's an equal number of samples from each region, and standardizing the component that is, so say, leaves every time, stem every time, roots every time. As anyone who has cooked before knows, there are, you don't use the stem of things when you want to use leaves of things. They have different flavors, they have different components. You should use certain things for certain things. So why UV? I'm not going to lie. I mean, there are other techniques that could be used in a similar testing sense. For example, another paper, Barzadina and all, used HPLC and the exact same methodology, HCA, PCA, etc., to perform a very similar study. Um, However, I think it's important to take into consideration the ultimate goal of this study, which was to provide a method of analysis for small medicinal plant dispensaries, manufacturers in European regions that don't have access to you know incredibly expensive piece of equipment like HPLC. So for that sense, affordability would be a real reason why. A cheap nano drop system or UV system could be $16,000 as opposed to hundreds of thousands of dollars for like an HPLC. Portability, another huge advantage here. This is a nano drop, a thermo nano drop, not sponsored, but this is something that I use in my work. I can carry it around to different buildings, safely, and something you can't do with larger pieces of equipment. And of course, there's always non-destructive nature of it. You need a small amount of these samples to do an extract with, and then you put in a cuvette. You can use the cuvette multiple times. You can wash the cuvette, and then you need so little of the sample itself that you're not burning money. If you, in the case of these companies that would be using this technique. There are many bioactive components in these medicinal plants that have been characterized using the absorbance features of the UV vis region. Um, and I think this team successfully proved their idea that this would be a viable option for these smaller companies for that are dispensing historically known medicinal plants. It was very interesting as someone who used UV vis a lot um, to see what it's truly capable of if applied correctly. Thank you, and I enjoyed reading about these papers.